Okay, if you look or turn in your journal to It's What's Inside That Counts, we're going to look today at what's important about the domain of our square root functions. If you look at the very top of this, it says that square root functions have and then you've got some blanks you need to fill in. Square root functions have what we refer to as a restricted domain. Square root functions have a restricted domain. And then it asks the question over here, what does that mean? You're going to have some questions today about finding the domain when you're looking at a graph. So as far as what it means on a graph, there's places where the function or your square root just will not go. Remember yesterday you guys were working on moving the endpoint around, and then you would sketch your function. If you look at the parent function, what you'll notice is that this particular function, this parent function, does not go over here in our negative x values. So that's not part of our domain. The domain for this particular function, by looking at it, I look only at the x-axis. I see that it starts at 0 and it goes to the right. So if I had to write a domain from looking at the graph, I would want to see where it starts on the x-axis. In this case, it is 0. And of course, it's going to the right, so I would say x greater than or equal to 0. And that would be the domain for our parent function. But you can do that with any graph. Just kind of look at where the square root function starts, where the endpoint is. Look at that x value. And if it's going to the right, it's going to be x greater than or equal to whatever x value it's starting at. It works the same way if you're looking at a table. There are some x values in this table that we know that we just cannot use. If I look over at this table, -3, I don't want to use that because it gives me an error. A -1 also gives me an error. So what I want to do is look at the x values, where they start working, and where they start working at, that's where my domain would start. Now if we were to put, again, this is the parent function, if you were to put this in your calculator and go and look at your table, you would notice errors at -3, -2, -1, but at 0, they left the 0 out of this particular table. At 0, you would have an answer over here in the y column of 0. So where the x values start working, that's what we would want to include in our domain. So for this one, again, it would be x greater than or equal to 0. But when you're looking at a table, it's where your x values begin. The reason this occurs, the reason we have a restricted domain, is because of taking the square root of negative numbers. If we try to take the square root of negative numbers, you guys know that your answers are either going to be imaginary, what we refer to as imaginary, or we might use the word complex, but not real numbers, not numbers that we can find on the number line. So the reason we have a restricted domain is because the square root function, we're not able to take the square root of negative numbers and end up with a real answer. We end up with something that's imaginary or complex. So because of that, we want answers that are real numbers. And because we want answers that are real numbers, we can only take the square root of positive numbers. So today what you're going to look at is finding the domain of square root functions. And the way you're going to do that, kind of a simple process. I say simple, but it involves some algebra. You're going to take the expression that's inside the radical. Only the part that's inside the radical. It doesn't matter if there's a value being multiplied in front It doesn't matter if they're adding or subtracting something out here. You're only going to take what's inside or underneath the radical, and you're going to set it greater than or equal to 0. Set it greater than or equal to 0. Of course, that notation would look like this. Greater than or equal to 0. Once you have done that, then you're going to end up solving your inequality. And what you have solved for will be your domain. So if we look at the example that they have over here in the box, remember what we talked about at the beginning is that what's underneath the radical cannot be a negative. If it's a negative, we're going to end up with imaginary or complex answers, and we don't want that with our square root functions. So whatever is underneath here has got to be positive. All right, it's got to be positive. So we're going to take what's underneath there, in this case 2x minus 5, and we're going to set it greater than or equal to 0. And this is going to help us find our domain. So I'm going to take this expression and we're going to actually solve for x. So the way that we're going to do that, we're going to of course get rid of minus 5, and so we would add 5 to both sides. I'll end up with 2x greater than or equal to 5. And then we would take this expression, if you want x by itself, if they're multiplying by 2, we are going to divide by 2. And we're going to end up with x greater than or equal to 5 divided by 2. You could leave it 5 halves. You could go ahead and divide it out. It would give you the decimal value of 2.5. Right? And so this, x greater than or equal to 2.5, that would be the domain for this particular function. Only values that were equal to 2.5 or greater, if you were to plug them into this square root function, would actually give us answers that would work, that would give us real number answers. So we're going to come down and look at the 3 examples at the bottom of the page. Again, what I want to remind you as you go through and do some of your work on your own today, the only thing that matters is what's underneath the radical. So as you go through the homework or the classwork today, if there's a number in front of the square root symbol, it doesn't matter for the domain, you just leave that alone. If they're adding or subtracting a value out here, that does not affect your domain. It's simply what's underneath the radical. All right? So whatever is underneath here, in this case 5x plus 14, so just what's under here, has got to be greater than or equal to 0 in order for us to get a good answer. So we're just going to take this expression and solve it for x. So the first thing we're going to do is subtract 14. That's going to give me 5x greater than or equal to a negative 14. Then I'm going to divide by 5 because they're multiplying by 5. So to undo that, I divide. And I'm going to get x greater than or equal to, and negative 14 divided by 5 will come out as negative 2.8. Or you could leave it as negative 14 over 5, since that is a reduced fraction. But this would be our domain for part A. We're going to do the same thing over here on B. All right. You're going to take what's underneath the radical. So in this case, it's 3/4 x minus 12. For our restricted domain, it's got to be greater than or equal to 0. So we are going to add 12 to both sides. That'll give us 3/4 x greater than or equal to 12. I'll be right back. So the last thing we need to do, sorry about that, we're going to take this 3/4 x. They're multiplying by 3/4. We're going to divide by 3/4. Remember when you put that in your calculator, put that in parentheses. So this will cancel and we'll be left with x greater than or equal to. You're going to put 12 divided by, and then in parentheses, 3/4. That would give you a 16. And so this would end up being our domain, x greater than or equal to 16. Now, another way that you could do that, 3/4 right here, you guys could multiply by 4 and then go in and divide by 3. Either way, you're going to end up with the same thing. If you choose to do it this way, remember 12 divided by, you have to have this 3/4 in parentheses in your calculator. Alright, the last one over here, we're going to take 22 minus 4x, and we're going to put that greater than or equal to 0. We're going to solve for x, we're going to subtract 22. That's going to give me negative 4x greater than or equal to a negative 22. The last thing we're going to do is divide by a negative 4. But you've got to be careful right here with inequalities. Remember, when you divide by a negative number, divide and multiply by negative numbers, it's going to flip that inequality symbol. So I'm going to have to remember when I divide by negative 4 to flip this symbol, and it will become x less than or equal to, and then negative 22 divided by 4 would end up being 5.5, or if I wanted to write it as a reduced fraction, it would be 11 over 2. 11 over 2. You've got some practice problems that you're going to work on. Again, the last thing that I'm going to say to you is as you go through those practice problems, remember it's only what's underneath the radical that has to be greater than or equal to 0. If there's a value in front, a value that they are multiplying by, you don't have to worry with that. Same thing, anything out on the outside that's being added or subtracted, don't worry with that. It's just what's underneath here. If you are looking at a table and you need to find a domain, right, look at the first x value that is actually giving you an answer. In this case, there would be a 0 and a 0 over here. So that's the first place that it would start working, and so that's why we chose 0 on this one. It's the first x value that will give you an answer. And then the last thing, if you are looking at a graph, look at where it starts on the x-axis. In this case, it happens to be 0. If this had been shifted over to the right and it had started over here, I would have said x greater than or equal to a 2. It's wherever that endpoint starts above your x-axis.
I gave her all the answers.
Did you?
She's ready.
Trying to
Man,
make it
was your
recording.
working your lock?
It's very, yes, I guess I was coming out of it.
Yeah, your lock is useless.
Did they work on it? Sorry, Ray.
I
You
forgot.
could be a star on the field. Did my recording.
All the math teachers are gone today.
What is this? I know this is what y'all are going to want to watch.